You know, there are times in one's career that define who you are, but the one that really early on led me into the direction of gene therapy was during my research, I studied the basis for this disease, Lesch-Nyhan syndrome, and got to know many of the children who were affected by this. And there was one young man who I got to know very well, and it turned out during one of his stays with us in Ann Arbor, identified the specific mutation that caused his disease. It was incredible. When I met his mother, I, with incredible excitement, shared with her this story and that we found the mutation that caused his disease. And she looked at me and she asked, "How is this going to help my son?" And at that time, it's like I was punched in the stomach. And it struck me that, in fact, this incredible science wasn't going to help him. From that moment, I really tried to develop a concept around how to not only treat him, but treat others that have diseases like him. And that was in the very early days when there was just early whispers of gene therapy. And I said, that's it. Gene therapy is really the ultimate treatment for patients that have disease due to single gene defects.
In the world, they affect a total of about 350 million people. So while individually, by definition, very rare, taken together, they are not so rare. In fact, they are more prevalent than all cancers combined.
When I first met him, he told me about his aspirations and his goals and his plan to cure rare diseases in children.
Gene therapy is to introduce the normal version of that gene into your cells to treat the disease at its root. But in order to achieve that, we need to technically develop approaches that just weren't available before. There have been attempts over the years to try different approaches, but the one that seems to work the best and the one on which the entire field has been based on is the concept of using a virus. That sounds crazy. Why would you give someone a virus? Basically, what I've been trying to do for 3 decades is to engineer viruses so that they don't cause disease, but using the power of a virus that very effectively and efficiently can seek out our cells, but in this approach for gene therapy to deliver a therapeutic payload. The trajectory of gene therapy, which basically chronicled my career, followed that of other cutting-edge innovative technologies where there's this exuberance and excitement and enthusiasm for it tends to get ahead of itself, and then there's this decline or crash. But the way that I operate is I sort of don't look back. So when I saw that, all I knew is we had to move forward. We had to move forward fast. We had to work harder, and that's what we did.
We talked about this journey. He said it wouldn't be easy, but together that we would make it through. I had no idea in my wildest dreams that we would be at the forefront of changing the face of medicine.
We refocused our efforts around the turn of the century towards vector discovery because we did not believe that the technology that was available was sufficient for gene therapy to realize its potential. We discovered this family of AAVs. We tested them in model systems, and I knew from the first experiment this was a game changer. I remember that lab meeting where a scientist had injected into a mouse a vector based on AAV8, and I was used to seeing very spotty, limited gene transfer with the old technology. It's depicted in this sort of graphic representation of speckles of blue. Each speckle is a cell that's been corrected. And then we injected our AV8. It was all blue. And I knew at the time, with that one experiment, with that one slide in that moment, that we probably have something now that's going to make a difference.
He's created vectors that allow genes to be delivered to patients that work better than any vectors that existed before. He realized that that was what was needed to change the course of the field.
Discovering the technology that was broadly useful was the first step, but it's only the first step. The next thing we did was we aggressively shared it with everyone. So right now, there are 26 companies that are using vectors related to our technology, involving almost 60 different programs. So it just sort of exploded, and it's only going to grow.
Quincy, our 4-year-old, has a very rare neurogenetic disorder called Angelman syndrome. Coordination's really hard for kids with Angelman syndrome. And because of that, she has a lot she wants to say. And when you ask her to talk, she opens her mouth and tries to talk, but she can't. Like she wants a hug, or she's hungry, or she's thirsty, or she's tired. When you have a kid who has so much that they want to say, and it's so hard for them to let that out, all you want to do is provide for them to make that easier. With activating a gene or replacing a gene that she's missing, we can give her all of that back.
You know, Allison just struck me as someone who I wanted to work with. It was personal. She's just so positive, smart, supportive, relentless.
Finding Dr. Wilson was the biggest blessing that has probably ever happened to our family, and I would venture to say our community.
She never stopped, and we've affiliated with that foundation and actually have made a significant commitment to try to develop gene therapy for it.
The fact that he was willing to take this on as one of his small handful of disorders meant the world to me. It meant that this was bigger than me and that I can trust somebody to help her.
We came into the world of rare diseases a little over 20 years ago when our then 15-month-old daughter, Megan, was diagnosed with Pompe disease. You're starting to see a convergence of people wearing a lot of hats. So for me, it became a hat, one hat was as a dad. And then very quickly, when we realized this was a race against time, I had to become an entrepreneur. And I came into the field to start a biotech company focused on rare disease medicines. Jim Wilson is thinking about how do you deliver these gene therapies to everybody in the world? And I think that has enormous potential to change the course of human health for literally hundreds of millions of people.
This has been a journey for me of over 3 decades, and it's exciting. Society is excited about it, but it's only the beginning of a revolution.
I have never seen him more excited or more motivated in the work that he's doing today. He's able to focus more on finding that light at the end of the tunnel.
When I think about my career and think about the mark I'm going to leave, it was based on that moment when I was a graduate student. That's the drive. And until we're done, we're not done.
He has my motto, things are either possible or impossible, and there's no in between. And he realizes it's possible, and he's not going to stop until he is successful.
His vision and his perseverance, it's contagious.
It has to do with who influenced me in my life. And probably the largest influence was from my mom. She taught me the Midwest work ethic, but the one thing she always told me is you got to finish the job you started, even when I was a little kid.
After 35 years, he has never backed down. He has never given up. It has been challenging for him, but he takes those challenges and he works even harder to move forward.
I hope that people will remember me as Johnny Appleseed. that I'm the guy that planted the seed with technology and science that then have led to cures and treatments for patients with many different kinds of diseases. At the core, I'm a contrarian. And I do not accept dogma or traditional wisdom. I always challenge it. That sort of forces me then to brave new territory, to think out of the box, so to speak. And I think kind of like it.